So hello everybody. Can everybody hear me? Okay. Well, thanks. Welcome to reInvent. This is the session for performance and efficiency. So first of all, let me introduce myself. My name is Juan. I'm based out of São Paulo. I'm the principal go-to-market specialist for Latin America. Even though I'm based out of São Paulo in Brazil, I'm not Brazilian. I'm from Colombia. And I've been with AWS for about 6 years now. And with me, I have the pleasure to have these two people join me. So Kat Sweetle, which is a senior director at Nubank, one of our most impressive. So Kat, if you care to introduce yourself.
Yeah, I'm Kat Sweetle. I'm the Senior Director of Engineering at Nubank. I own the transactional infrastructure, basically everything from the CI/CD pipeline forward and all of the tooling and everything like that it takes to run and operate a service in production.
Thanks so much, Kat, for joining us. And David.
Hey everyone, I'm David Romeo. I'm the Senior Product Manager for EC2 Spot. I've been running the Spot business for almost 5 years. This is my third reInvent, so if I can have a show of hands who has more reInvents than I have. Oh, a couple of people. Who's his first reInvent? Oh, nice.
Wow.
Awesome. So this is actually my first time talking in a breakout session. I've done workshops before. I'm really excited to be here, and I hope you get a lot of value out of this talk.
Thanks, David. So let's get started. So this is the agenda for today. First of all, we want to walk you through strategies and techniques to be more efficient in the cloud. And that goes through topics such as right sizing, elasticity, and scaling. And we'll go through purchase options as well. So Spot. I wanted to run a quick poll on Spot. Who of you have heard of Spot instances before? Nice. Oh, pretty much everybody. Of those who raised your hands, which of you are already using Spot instances? Well, that's impressive. That's about 50%. That's usually the right proportion. So that's going to be the first part of the presentation. I hope you get some new information on Spot and efficiency. And then David is going to walk us through purchase options and savings plans and things like that. And finally, Kat is going to walk us through the Nubank's journey to efficiency. Really looking forward to that part. So what do we mean by savings? So savings has two aspects. One aspect is to minimize unnecessary. And I'm going to run another question. I promise there are not many of these, but of you that are already through the EC2 service, can you guys hear? Is it static? Is breaking up? Is it better? It might be my phone. How about now? Is it working well? Okay. Just let me know if something, I'll just let the technician know. But anyway, there are two aspects of cost. Now it's not good. How about now? Now? Not good? Is it better? Okay, let me keep going, and if it's not good, just let me know, okay? We're having issues with this, with sound. Okay, anyway, I'll keep going, and please let me know if it doesn't work. So, question. Okay, question. So, okay, probably I don't even need this. The other two mics are working. Okay, this one is working well. Well, anyway, I'll speak louder. So, who of you have ever left an instance unattended, just forgotten about it? Okay, so one thing is to minimize the cost for that instance. How about now? Is it okay? Okay. So one thing is to pay the least amount of money possible for any given instance. The other one is to make sure that you are using those instances, those resources in the best possible way. And obviously there's a third aspect of that, which is carbon footprint. But you have to make sure that once you are making efficiency changes and paying less and using the right purchase methods, you want to make sure that is not going to impair your ability to innovate. and that isn't going to impair your customer experience. So that's really important. So that's the balance of those two things. And then it comes the concept of elasticity or the elastic compute cloud. So this is kind of a function over time of how your predicted demand might behave. So this is probably very known to some of you which do capacity planning. So this is kind of what you will expect on terms of customer demand or predicted demand. And actually, when we look at the past or the present for some, if we go to the kind of on-prem world, you'll see that the investments that you have to do to be able to meet that capacity demands is reminds this kind of a step function, which is you're going to invest thinking on the capacity that you need for some time, making sure that it's going to meet your requirements. And then once your requirements or your demand are kind of at the same level, you'll have to do more investments, and it looks a little bit like this step function. But actually, your customer demand looks a little bit more like this. It's like this curvy line that it goes up and down around your predicted demand. And what you want to make sure is that whenever you are on the low side of use, you want to make sure that you are not spending more than what you need. But if you've already invested on capacity, there's some opportunity cost, which means you have those resources that you are not using, and then you have low usage on those resources, which means there's an opportunity cost there. And in some cases, if your demand grows faster than you expect, probably you are not going to have enough resources to meet that demand. So that's kind of a lost opportunity. And then is where the elastic concept of the cloud comes in, which is you want to make sure that you fulfill capacity or fulfill resources based on that customer demand. So whenever it goes up, you fire up some new instances. Whenever it goes down, you turn off those instances. So you kind of follow that demand. That's kind of the promise of the cloud. But that actually, it doesn't necessarily work like this unless you use the right approaches to elasticity and scaling. So if you have too few instances, you're probably good from a cost perspective, but your customers might experience low performance. If you have too many instances, you're going to have great performance, great customer experience, but you are paying more than you should. So actually, you want to be on the middle, which is you want to have the right number of instances at all times. And that means that you have to auto-scale. So you don't forget instances that are turned on. So the promise of the cloud is that it becomes kind of a service instead of a purchase that you do. So it looks, and sometimes we make the comparison against electricity, which is whenever you turn on a device, it consumes and it generates cost. Whenever you turn it off, it doesn't. So that's kind of the way the cloud should work. But for that, you need the right auto-scaling policies, and because it's not going to happen on its own, like automatically. Automatically, as soon as if you have the right techniques. And for that, we have a number of services that provide auto-scaling. On one side, you have dynamic scaling, which means you want to make sure that your resources scale based on the actual demand, and you can use some triggers for that. One example of dynamic scaling is what we call simple or step scaling, which is you are going to define a metric like CPU utilization or memory or anything like that, and whenever you reach or it reaches certain amount of a certain threshold that you define, let's say 60% CPU utilization, then based on that metric you want to fire up new instances. So that's step scaling. It's going to react based upon customer demand. And on that same, that's kind of the simplest way of auto-scaling based on metrics. There's another one which is target tracking, that instead of firing up new instances based on metrics, you try to meet certain threshold all the time, like a thermostat. So let's say that you define like 60% CPU utilization all the time, and automatically new instances are going to be fired up or down just to make sure that you are meeting that 60%. So whenever it goes up, then new instances are going to be fired up, and whenever it goes down that 60% level, instances are going to be turned off. So that is dynamic scaling that works very well. That depends on your workload demands, you can use one or the other. But in some cases, events such as Black Friday, for instance, are events that you can predict. Or there might be streaming situations like sporting events. There was a very a large sporting event that happened a couple of months ago, and this was a really good example of it. Perhaps you've seen it, because I don't want to mention specifically what it was, because I don't think I have the rights to to mention that. But anyway, streaming events, for instance, are things that you can plan ahead for, and you can fire up on new instances and make sure that you meet those that demand before it actually happens. And in some cases, that might be better than doing auto scaling, because those events happen so fast that you really don't want to wait to automatically scale up because it might be too spiky, for instance. So in that case, you have the option of doing schedule scaling, which is you are going to define a day and a time in which you want to fire up new instances, and you kind of know already, and you have a good prediction of how many instances you might need. So you do schedule scaling. And on that same lines, you can do that sort of a schedule scaling based upon the behavior of your workloads and your demand that you've seen on the previous weeks and months. So this is actually a way in which you can scale predictively, but based on the behavior that's happened before, using machine learning and algorithms that learn automatically those patterns. So that would be predictive scaling. So you can combine any of these four auto scaling methodologies to make sure that your demand actually meets the amount of resources that you have. Is this mic okay? Okay, perfect, thanks. So that's elasticity, right? And auto scaling is the right approach. So you can kind of forget about the way that you need to start or turn off instances. But then the other thing that you have to be aware of is the kind of instances or the type of instances that you're using. You want to make sure that you are using instances that meet your workload's requirements precisely. The more precisely, so you don't have more performance that you actually need on each one of the instances, and on the other side that you don't have left than you actually required. So who's been more than 10 years, who's been utilizing AWS services for more than 10 years? Okay, who's been utilizing it for like 15 years? Okay, so 16 years ago, we launched EC2. We had then just one instance. It was the M1. It was an x86 based instance. There was just one of it, and which meant you had to use that one regardless of the application requirements that you had. So either use it or lose it, kind of it. But since then, we've added exponentially the number of instances that you support. For the ones that have been around for the longest, you probably have seen that number increase up to 800 different instance types. You can organize or select instances based on, or choose instances based on different types of categories, such as general purpose instances, or the ones that are more CPU intensive or memory intensive, or the ones that require GPU. And then we add to those instances different capabilities, from the smallest ones, the nano instances, to the really large ones with a lot of vCPUs and lots of memory for in memory databases, for instance, different types of networking adapters. So we have really lots of options, and the purpose is for you to have the right instance for the right job. We've been able to add this innovation for many reasons. One of which that I wanted to mention rapidly is the fact that we have silicon innovation, which means we have the capacity and capability of doing our own chips, our own semiconductors, our own silicon. And one of the projects that we built around that's enabled this the capacity for us to be able to increase the number of instances is the Nitro platform. So Nitro is pretty much a hypervisor. So it's the way by which we do virtualize our instances. And this is based on hardware, which means whenever you use an AWS instance and you get, let's say, 4 vCPUs, let's say 32 gigs of RAM, you are actually getting 4 vCPUs and 32 gigs of RAM, because none of that capacity is being used for virtualization. That's being done by hardware. That's Nitro. And there are a number of other projects that have come from this capacity that we built internally. One of which is Graviton, which I'm going to go deeper in a while. But we also have Inferentia for machine learning workloads and training. So that's really unique, and that's really particular of AWS. And then we have our purchase options on top of that. So you can use on-demand instances and savings plans. But I'm going to leave that explanation for David. That's going to be taking more on spot, particularly later on. So let me change gears just a little bit and go a little bit deeper on Graviton. And here I hope this is my last question. That is, who of you have ever heard of Graviton instances before reInvent? So most of you, but not everybody, right? And from those who raised your hands, who is using Graviton already? About the same. Okay, cool. So Graviton is a microprocessor. It is based on the ARM microarchitecture. So the ARM microarchitecture, for those of you who are gamers, you are probably very familiar with this. So we basically have two options in the cloud. It's either x86, which is either Intel or AMD, or ARM-based microprocessors. Graviton is ARM-based. It is basically a microprocessor that is being designed around ARM, but it's been designed to meet specific cloud requirements and specifications. So actually, we got the capacity of creating a CPU that meets cloud workloads and cloud demands. And we did brought ARM microarchitecture to the cloud for a number of reasons, but the most important ones, I would say, are both price and performance. So the ARM microarchitecture is being used for, it actually has been created in the 80s, but it really kicked off in the 2010. Most of the mobile phones today are using microprocessors with ARM architectures. It's 99.9% chance that the mobile phone that you have in your pocket is running with an ARM microprocessor. And it makes a lot of sense for mobile devices because the energy consumption is very low in comparison to x86. It's very low, which means in the mobile world that you'll have longer battery lives. In the data center, that means a lower cost of operation. It spends less energy to operate, which means the price to maintain it and keep it running is lower compared to x86. So that's the first thing that I wanted for you to remember, is that Graviton, the price of Graviton is lower than x86. One of the reasons is because it's more energy efficient. And in average, if you compare Graviton against x86, it's at least 20%. The price is 20% lower than a similar equivalent x86 instance. Obviously, since they are different architectures, they are different instruction sets for both ARM and x86, but that doesn't mean that there is not a large software ecosystem for ARM that has been built for decades, so it's there. Most Linux distribution works for both x86 and ARM, so there's a lot of support for ARM architectures, and then applications, open source, things such as open source databases, and even commercial software options that support ARM already. So there's a large of support for, a large software ecosystem, and it's really efficient from an energy perspective. 60% less power consumption than an equivalent x86. Graviton is being around for a while. This is not a new product. For the ones that didn't raise your hands, Graviton is not new. We are already on the 4th generation. We launched the first generation in 2021. Since then, we increased the performance of Graviton by 7 times, which means, this is a really mature product, and that shows on the number of different instance types that we have. I remember that at the beginning I said that when we launched EC2, we had just one instance. Now we have plenty of different categories of instances, different types, different options, And that applies not only to x86, but the Graviton on the same, similarly, which means if there's an option for x86, there's most likely an option in Graviton as well, which means there are options and family options. And the thing that you have to look for and remember is that Graviton instances have G on it, so you know it's Graviton, so that's an easy one. And then the easiest adoption path, if you wanted to take advantage of the 20% different price and the 40% actual price performance advantages of Graviton, is through managed services. Those things such as Lambda, for instance, you can run that on Graviton. All the or most of our managed database services are run on Graviton. If you are running RDAs, for instance, with an open source database or something that is supported with by Graviton, you can simply switch your instance type and you'll have 20% average saving overnight. So that's an opportunity that you don't want to be missing. That 20% is only looking at price, but if you look at performances, most of the times a 40% price performance ratio advantage on Graviton. So what can you run in Graviton? Pretty much everything that runs on Linux runs on Graviton and runs on x86. So as long as it is open source and Linux based, it's probably going to work on Graviton. So anything, open source things such as I said before, databases, that's a good example. But if you are already doing your own coding and you do have Java microservices, for instance, or based on PHP or any other interpreted language like Python, there are interpreters for both Graviton and x86, which means you can easily port something that you are running already on x86 to Graviton. And in terms of workloads, microservices and containers are typically things our customers use Graviton on: databases, analytics and big data, and definitely web or gaming services. So I'm gonna change gears now and pass on the mic to David.
Thanks. Can you hear me from here? Okay, thanks, Juan. So I want to talk about the different compute purchase options that you can use on EC2 and in general other compute solutions. Probably you've already seen some version of this slide if you've been a reInvent repeat. But we have the three main compute purchase options are on-demand, savings plans, and spot. On-demand is the building block of the cloud. How do you maximize savings on-demand? As Juan mentioned it, if you don't use it, turn it off. That's how you maximize savings. So if you're able to scale up with your demand and scale down when you don't need it, that's how you maximize your savings. There's no commitments for on-demand, and so this is the first go-to purchase option that you should consider. The second purchase option is savings plans, which gives you up to 72% over the on-demand cost. And this is for steady state usage, where you're able to commit for a specific hourly spend for periods of 1 or 3 years. And that's how you get the savings. You make a trade-off between a commitment, you always have to spend that, and you'll get the specific discounts. And then you have spot, which is spare capacity. We give you access to our spare capacity up to 90% discount, but because it's spare, it's more suitable for interruptible workloads because EC2 will still have the right to take that instance away. I'm gonna dive deep into savings plans and spot specifically for this talk. So let's talk about savings plans. So I'm a little bit ashamed to say this as the EC2 spot PM, but if you ask me what is the easiest way to maximize your EC2 savings, I would say it's savings plans. And why I say this is like the savings are really good, up to 72% of on-demand prices. So they're steep savings. They're easy to use because you only have to figure out what's your baseline spend and purchase a savings plans that cover that spend, and then the EC2 will take care of applying that discount automatically. You don't have to do anything much about that. And the third thing is that it's very flexible. You don't have to commit to a specific type of compute. You just commit to the spend, and depending on the type of savings plans, we'll apply it automatically across regions, accounts, instance types. And so there are 3 types of savings plans. Each one applies to different type of compute or applies a different threshold of savings. The most popular one is the compute savings plan, because it's the most flexible one. So it gives you up to 66% discount, and it automatically applies across regions, families, sizes, operating systems, and most importantly, compute service options. And by compute service options, I mean it applies to your Fargate usage, it applies to your Lambda usage, as well as your EC2 usage. So the most important part of the flexibility of savings plans is that you purchase it, and it doesn't matter if you make a decision of, hey, I was running on x86, I'm ready to take the step of Graviton. You don't have to worry that commitment that you make is no longer going to be applicable to your future x86 Graviton usage or previous x86 usage. You want to expand to a different region, don't worry, the compute savings plans will follow your discounts. You want to go serverless with Lambda and Fargate, the discount will still apply and will be applied automatically. Then the other flavor of this is EC2 instance savings plans, which gives you a little bit more discount, up to 72%, but it's restrictive to a specific region and instance family. You can still scale up once you're right sizing. If you decide that this is a specific instance family, you need a larger or a smaller version, the discount will apply automatically, so you don't have to worry about that. But it's restricted to a region and an instance family, so you need to take into account this. And finalizing the savings plans, you have to make sure that you understand that you're making a commitment, and that's how you get the savings. So when you're analyzing your baseline spend, make sure that you understand that it's going to be for at least a year that you will need to spend that money to achieve these discounts. Okay. So let's go to Spot. So as the Spot PM, it's my responsibility to say that Spot is the best way to maximize your EC2 savings. It's the best because it gives you up to 90% off, and it has no commitments. So let's start with debunking some myths of Spot. Spot is actually a purchase option. There's no different infrastructure where we give you the Spot instances. They came from the same 800 plus instances, same infrastructure, same hardware. There's no Spot backroom instances that we give you. So you can be sure that you're getting the same performance as on demand. The caveat is that it is actually spare capacity. So we are only giving you the Spot instances when there is no on-demand usage on that specific instance types, and so there's always be the risk that instance gets taken away with a 2-minute notice. So because the interruptions is always going to happen, this Spot instance model only works if your application is fault tolerant or is loosely coupled or is stateless. And there's a fourth characteristic that is very important, that is flexibility. And let's talk about that. So there are multiple dimensions of flexibility. You can be time flexible on when you run your application. You can be region flexible. But the most important are that your instance type flexible and your availability zone flexible. So for every instance type, let's say C5, 16x large, 12x large as an example, and every availability zone, let's say US East 1A, we have a set of instances in the data center. Some of them are being used by on-demand, some of them are idle, and some of them are running on Spot. So it's in your best interest that you don't limit yourself to a single instance type in an availability zone, because if you diversify and you're flexible about which one you can use, you maximize your chances of finding that spare capacity. So a good analogy would be if you want to book a room, you don't call the front desk and say, hey, do you have the room 305 available? It's very likely that the 305 is not available right now. But why are you limiting yourself to the 305? Why don't you do the 306 or the 405? There is no specific reason for you to tie yourself to a specific room, and there is no specific reason for you to tie yourself to a specific instance type when using Spot. You want to maximize your chances of finding the available spare capacity for Spot to work for you. And so we've made it pretty easy. We have 800 plus instances, but you don't have to memorize them. You don't have to go ahead and pick them one by one. We have a way that is called the attribute-based instance selection, where you just tell us what your application is. So you can tell us, hey, my application needs 4 vCPUs of memory. It needs at least 8 vCPUs, 8 gigs of memory, and for example, right now I'm not willing to do the jump on Graviton, so I need an x86 instance. So you give us the parameters. There's a long list of parameters that you can give us, and we'll infer out of the 800 plus instances which ones apply to your to your use case. So we've made it very simple for you to be instance type flexible. Once customers start getting into the idea of Spot and they say, okay, I'm flexible, I understand the more instance types, the better. But the first thing they ask us once they're on this path is they ask us, hey, why don't you EC2 give me the information about how much capacity do you have so I can make my decision on where to launch? And no matter how many times customers ask, we're not going to tell how much capacity do we have in our data centers. But we actually solve the problem for you. So the problem that customers have is like they want to tell us what is their preference. They want to either minimize cost, they want to minimize interruptions, or both. And we extended, like we give you a way for you to tell us that preference through allocation strategies. And for Spot, you can tell us exactly. Lowest price will put you into the cheapest instance available at that point in time. And no matter the interruptions, we'll land you there. There's another one, which is we look into the capacity, we figure out which is the deepest pool that minimizes your interruptions, and we'll put you there. And the one that we recommend is actually doing both at the same time, is looking both at the costs, looking both at the interruptions, and puts you into what we believe is the best place for you to run at that point in time. We also have allocation strategies for on-demand. So if you're flexible on on-demand and you have a set of instances that you can use, you can either tell us, hey, just use the lowest priced one, preferably, or if you have a priority list of, hey, this is 1, 2, 3, my best options, we'll follow that priority list for you. The allocation strategies are available on EC2 Fleet, auto-scaling groups, and Spot Fleet. Okay, so the final message I want to give you on the purchase options is that you don't have to actually commit to a single one. You can mix and match depending on your workload. And so there's a bunch of examples of workload types and how you can mix the purchase options. But I want to run through a couple of those. For a database, you know that you'll be running that 24/7 for a year, probably. You don't want to put them on Spot. Please don't put a database on Spot. It will get interrupted. You will lose your data. So for a database, you know you'll be running it for a long time. You have to right-size it, know how much you will spend, and purchase a savings plan for it. That's how you maximize savings on a database workload. But for other demand-driven, for other like user-based workloads like video streaming, game services, that follow the user demand, you don't have a good way to predicting that baseline spend, so you should be using either Spot or on-demand. And for video streaming and game services, if you don't want your end customers to be interrupted in the middle of the call, then you should use on-demand. But for other type of workloads where it's, for example, testing or like game sessions that are very short-lived, you can still use Spot. And then for the final thing is for any job-based workloads where the execution of the job is short, that you can either retry the job or can live within the 2 minutes, you should be scaling with Spot. That's the easiest way for you to maximize your savings, and you don't have to worry about how to implement the Spot, because we have a lot of integrations with EMR, Batch, EKS that will help you through that journey on using Spot for those specific workloads. With that, I'm going to pass it to Kat so that she can tell us Nubank's story through all of this optimization and EC2 efficiencies.
Thank you. Hello, I'm Kat. The first thing I want to say is I'm so thankful to have this opportunity to represent the hard work of so many Nubankers, some of whom are in the audience right now. It's a great honor. And then I also want to give you a little bit of context about Nubank. So we are a digital bank. And so what does that mean for the rest of my story? It means that if our app is not running, our customers are not having a good time. They can't walk into a branch, right? There are no branches. So all of this story, keep in mind that there's a really high need for reliability and stability. So we're not sacrificing on that in order to gain efficiency. Hope that makes sense to everyone. Important information. Okay, so Nubank, we are the 4th largest financial institution in Latin America. We have over 110 million customers. I think somewhere in the neighborhood of 60% of adult Brazilians are a customer of Nubank. It is very, very large. So we started in 2013 in São Paulo, Brazil, where we are headquartered. And then along came the expansion to Mexico in 2019. And then we have further expansion into Colombia in 2020. So now we have, actually these numbers are a little bit outdated because we just had our earnings call. So I can officially say that we have over 110 million customers across those 3 markets. The other thing I want to point out is that we keep our cost to serve very low. So I don't know how many quarters it's been now where we have kept our cost to serve, monthly cost to serve an active customer under $1. And the slide says 90 cents, but in our last earnings call, we announced that for our last quarter, it was 80 cents per active customer. So efficiency is a very key part of how we operate. All right, and as part of that efficiency journey, we have kind of these phases. So we start off on just good old EC2 and then make the move to Kubernetes. And then in 2020, we start experimenting with Spot. There were some other things happening that we knew we could anticipate a lot of scale happening in our market. Brazil had debuted an instant payment system that we thought would really take off, and boy, did it ever. Then in 2021, we IPO'd, woohoo! So that put additional, right, like cost scrutiny, efficiency scrutiny on our operation. We also migrated to EKS. In 2022, we started to adopt Graviton. And now here we are, 2024, we have 50 enormous clusters. We're a very, very, very large operation. But throughout this journey, we have achieved this super high scale and still kept the cost of the operating platform low by necessity. So I always get this question, right? Like, oh, you make it seem really simple to be running all these transactional workloads on Spot. There are certain things definitely about our architecture that make us unique and well suited to Spot. So the first thing, there's 2 officially supported programming languages at Nubank. Clojure, JVM, right, which does make it easier to experiment with different things, and Python. That's it. It's a very homogeneous environment, okay? There's over 2,000 unique microservices all running in EKS. We deploy a lot. There's somewhere in the neighborhood of 200 deployments a day for backend services. So a deployment is a type of disruption, right? So our services are pretty tolerant of that. We also do not have any great need for specialized instance types. In case you haven't picked up on the theme across all of the speakers so far, diversification is pretty much it. And you can see from this chart, we make use of many, many, many different instance types. And at Nubank, we have something awesome, in my opinion. We have our engineering principles, and one of them is canonical approaches consistently applied. What does that mean? It means when we want to make an efficiency change in the platform, we can pretty easily roll that out to all of the services because those services are making use of canonical approaches. So it does make it easier for us to experiment and roll out platform changes. All of those things combined do make us a pretty good candidate for the Spot market. Okay. I told you things like, oh, these things make us a good match for Spot. These are the things that I wish someone had told me before I started in on my beautiful Spot journey. So the first thing, you should know the startup time for your services or your applications. And I don't mean just the startup time, but I mean the entire lead time until that service is hot and performing, right? Because you get a 2-minute clawback warning with the spot market. If you have a very long startup time, you're going to have not a lot of fun, right? Yes. The second thing, some people are touching their headphones. Is my mic working? Okay, thank goodness. All right. The second thing, monitor the interruption rate for services. So how frequently are instances being clawed back? And be very careful about aggregating this, right? So you could have, like I have many services, yes? So if we look at the total disruption rate, it might be very low, but if I slice that or use different lenses to view those services, all of the workloads, I could see one service or one flow where the interruption rate is much higher. So you have to be able to disaggregate the interruption rate. The second thing, something you and I have talked about, we have to manage the total disruption rate. So experience this from the point of view of a service. Whether it's a spot clawback or it's some sort of consolidation or bin packing event, from the point of view, the service doesn't care. It's just, I have to go, I'm sad, I have to go live in a new place now, right? So look at the total disruption rate for a service. The next thing, I strongly advise you to know ahead of time what is that magical spot discount number for you that's going to make spot a good trade-off for you. Don't wait until you're in the moment thinking, oh goodness, is this a good trade-off? Because you are paying, you do have some amount of instability, right? The next thing, understand the total cost of ownership for your spot strategy. So spot costs a certain amount, you're purchasing that compute on the market, but keep in mind, like, you are paying for that lead time to start up the service, and you are, incurring a little bit of instability. And so keep in mind the total cost of ownership for your spot strategy. And the last one, diversify. And I know I said that on the previous slide, but I feel like about every 6 months I need a reminder of how diversified we actually need to be in the instance types that we allow on the spot market. So these are all the things that I wish I knew. What are the business results of Nubank's spot strategy? So I'll go back, I think 2021 was the first year where we didn't make any on-demand reservations. We just said, let's let it ride. And it was good. It was all good, actually. So we avoided spending $800,000 in one day on Black Friday. Obviously a huge day. Didn't have any capacity related incidents or anything like that. Then the next year, so year 2 of running Black Friday, all spot, I have this chart just because I think it would be hard for you to pick out Black Friday. Like, certainly one of the bars is higher than the other, but as far as what is the spread between the different purchasing methods, it's not actually that different for us for Black Friday. So I think that is a sign of success. And this year, again, we ran pretty much our same strategy, which is that we had almost no reservations, and everything was fine. I didn't get paged at all. So yes, great day. I will say, right, spot is part of our purchasing strategy. So again, we are pretty diversified here. We purchase on spot, we have savings plans, we have on demand, all these things. So part of a strategy, yes? And it has borne great results for us. So this is the average vCPU costs clearly going down as we adopt spot, we adopt Graviton, all of those things. So now the Graviton part of the journey. Did anyone read this blog by Liz Fong-Jones where they adopted Graviton at Honeycomb? Yes, this is an awesome blog. Highly recommend you read it. It definitely made the rounds in Nubank engineering. So we start hearing this buzz about Graviton and decide to start experimenting with that. So that was 2021. And then in the next year, in 2022, we started to adapt the canonical approaches that we have so that there's an x86 version and then there's a Graviton version. Okay, so the base service image, the CI/CD pipeline, all of those things where we provide each of the service owners opportunities to experiment with Graviton. In 2023, we discovered that Graviton is a great fit for our analytical workloads, which was awesome. And where do we stand today? We run quite a bit of Graviton, and we have seen a really good price performance. And of course, like Juan mentioned earlier, the added benefit of reducing our carbon footprint because it is a more energy efficient architecture. Of course, there are some challenges for us. We run a lot of workloads in the São Paulo AWS region, and we also run other workloads in other regions across the world. Graviton is awesome. It doesn't magically appear in every region at exactly the same time. So it does roll out region by region, and that's something that we have to think about. Also at Nubank, we have this idea that kind of radical ownership, you build it, you run it. That means that we, down in my world in platforms, we are dependent on those teams that own the services to make the choice to go to Graviton. So sometimes just a little gentle nudge is called for, yes? Okay, so what do I wish someone told me before we started the Graviton journey? Number one, canonical approaches make this journey so much easier. If you're going to be dependent on a bunch of disparate service teams adapting their base service image and coming up with tests and a way to roll this out, your life may or may not be very difficult. For us, it was a lot easier because we do have these canonical approaches for developing and operating a service. Of course, you should test, right? Not every service, not every workload experiences the same performance on Graviton. So like anything else, test it out with different types of workloads. Again, availability of capacity matters a lot. And here, I mean, is it available in the region where you run? And also, if you're combining this with a spot strategy, is there excess capacity in the region, right? So availability of actual capacity matters. And then I think we're in the age of ESG, right? And we want to be good global citizens. So I do think that as you're looking at Graviton, there has to be something in the is it worth it question about the green advantage of Graviton, that it is more energy efficient and reducing your carbon footprint. And again, I would advise you ahead of time to think about what level of performance would justify the investment in migrating to Graviton. And that number, of course, will be different for everyone. So what is next for Nubank? What will I be talking about next year when I arrive here? When we started in Brazil in 2013, we were in one country, we had one product, the credit card. Now we're in 3 countries, we have many, many products. We have a bank account, we have lending, we have insurance, we have all of these different things, and we're expanding into new verticals. So we now have mobile phone service. And I think that now we need to diversify even more and have even more nuanced strategies when we talk about how we purchase compute. So I think next year, when I show up here, I will be talking about even more nuanced strategies that are developed for the different combinations of where we're operating and what verticals we're operating. Okay, I think that's it. I'm very, very thankful that you all chose to join us today. Yeah.
Thank you.
Thanks.